So this was pop quiz 3, which was related to electricity and magnetism questions. Energy and power MCQs, all energy and power questions were there. An air conditioning unit, a lamp, an electric fire, all receive the electrical energy. From which of these devices all the energy eventually transferred to the surrounding? So eventually what will happen? They don't keep this energy, like they all transfer energy to the surrounding. So air conditioning unit is there, or air conditioning unit is there, or a lamp is there, or electrical heater or electrical fire. They all the electrical devices transfer all of their energy to the surrounding. Useful and unuseful or not useful, that is a different thing. But all energy transfer to the surrounding. That's why A is the right answer for this. In question 2, there's a current of 5 ampere in the resistor. So we have I. The potential difference across the resistor is 24. So we have voltage and the energy transferred in the resistor in 1 minute. So that is the time, but time should always be in seconds. So 1 minute equals to 60 seconds. How to work out energy transfer? Energy transfer, if we have voltage, current in time, so then it will be VIT, where V is the voltage, that is 24. I is the current, that is 5, and T is the time, that is 60. So we multiply all of them. So it will give us 7,200 joules. So D will be the right answer. So whenever a question is there, you're getting answer in joules. For getting answer in joules, the time must be in seconds. If we want to find the answer in kilowatt hour, then in that case, the time should be in hour. Otherwise, the time should be in second. The next question, the average current during a lightning strike between a cloud and the ground is 1.5 exponent 4. So we have the current I. The lightning release 3 exponent 8 joules. So we have the energy. And it lasts for 2 exponent minus 4 seconds. So we have the time. What is the average induced or average electromotive force between the clouds and the ground? Again, we'll use the same formula, that energy, when we have voltage, current, and time, E equals VIT. Where E is the energy, that is 3 into 10 to the power 8. V is the voltage, that is unknown, the electromotive force. I is the current, which is 1.5 into 10 to the power minus 10 to the power 4. And time is 2 exponent minus 4. So the time is equal to 2 exponent minus 4. So we multiply this by 2 into 10 to the power minus 4. So this whole factor is multiplied. Other side it will be divided. So when we divide, we'll get C as the right answer. In question 4, a water heater is connected to 230 volt supply and the current is 26 ampere. It takes 20 minutes. How much energy is supplied? So we have the voltage, we have the current, and we have the time, but time should always be in seconds. So you have to multiply by 60. So 20 multiplied by 60, it will be 6 multiplied by 2, 12. So it will be 1200 seconds. So we'll use a formula, energy equals VIT. 230 times 26 times 1200. So when we multiply all of them, we'll get 7.2 exponent 6, or D will be the right answer. So the same formula we use to solve the first 4 questions, that energy is equals to VIT. The circuit shows a 12 volt battery. So we have voltage, we have the resistor. How much energy is transferred in 2 minutes? So how we can work out the energy transfer in this case? Again, the time is in minutes. We have to convert into second. So it will be 2 multiplied by 60, which is 120 seconds. So if we have the voltage and the resistance, voltage, resistance, and time, what formula we use to get the energy? In that case, energy is equals to V square over R multiplied by T. If it was voltage, current, and time, then it will be VIT. Because power, when we have voltage and resistance, power is V square over R. So this is actually representing a power. So it will be 12 square divided by R, which is 3, multiplied by the total time. Time is equals to 120. So this will give us the total energy. When we simplify, D will be the 5,760 joules will be the right answer. So it's important that you learn the formula to work out the energy depending on the parameters which are given to you. A torch has a simple circuit. The torch has a simple circuit which is operated by a 3 volts lamp, 3 volts battery and a lamp, a 20 milliampere. So 20 milli means 10 power minus 3. So it will be 20 into 10 power minus 3 amperes. And it is used for 5 minutes. So if we use for 5 minutes, the time should be in seconds. So we multiply by 60. So it will be 5 multiplied by 60, which is 6 multiplied by 5, so 30. So 300 seconds will be there. You need the energy. So how to work out the energy? Energy is equals to VIT, where V is the voltage, which that is 3. I is the current, which is 20 into 10 power minus 3. And T is the time we use for 300 seconds. So multiply by 300. So 18 joules will be the right answer. In question 7, the table gives data of 4 different electrical devices. Which device develops the greatest power? How to work out the power? The power is actually a product of voltage and current. We have the formula P equals VI. So here 12 multiplied by 3, that will make 36 watt. The second one, 110 is multiplied by 0.4. What's the answer? 110 multiplied by 0.4? 44. Okay. So this will be 44 watts. This is 400 kilovolts. 400 kilovolts means kilo means 10 power 3. So 400 exponent 3 multiplied by 0.1 milliampere. So it will be 0.1 into 10 power minus 3. When you multiply plus 3 and minus 3 actually cancel out, and 400 into 0.1, that will make 40 watts. 240 multiplied by 0.2. What's the answer for this? That's equal to 48. So this is giving us 48 watts. The question is, which device develops the greatest power? That's D. So you have to multiply voltage with current and check the units, because the voltage, it must be in volts and the current should be in ampere. Question 8, a circuit containing a cell, the EMF is 2, the current is 2, and the time 2 minutes as well. But time should always be in seconds. So what we do, it will be 2 multiplied by 2 multiplied, time is in minutes, so multiply by 60, so it will be 120. When you multiply all these factors, you will get the energy that is equals to D. 480 joules. So if the answer of energy in joules, the time must be in seconds. If the answer of energy is kilowatt hour, then the power should be in kilowatt and the time should be in hour. Put a ring around the names of the metal which are attracted to the magnet. So aluminium is not attracted to the magnet, copper is not, iron is, mercury is not attracted, magnesium is not, steel is attracted, tin is not attracted. So iron and steel are the magnetic materials. One is a soft magnetic material, which is easy to magnetize and demagnetize. One is a hard magnetic material. Figure 11.1 shows a magnetic pattern of a bar magnet on the diagram. Label the north and the south. So the magnetic field must always point out from north and into south. Here we have north and south, but student just make this north and south. There, it is not possible for a magnet to have a monopole. Like you don't have a magnet with only single pole. Magnets always exist as a dipole. Magnets always exist as a dipole, like two poles will always be there. So if this is south, this will be north. This is north, this will be south. So always, so there is always dipole. So some students, when they send this answer, they just write north and south. That's why I put wrong here. Why? Because a magnet, for a magnet, it always exists as a dipole. Here,